I'm here to talk today about, I actually regret the name of my talk a little bit, Advanced Design Systems Considerations, mostly because it's a mouthful, but also I mean advanced, less like advanced math and more like advanced osteoarthritis or something, right? I want to talk about what the work is once you convince everyone at your company to use your design system, and once you're done building out all the name brand components. I work at Stripe on our design system team. We're 2 designers, 2 engineers, and a manager for a total of 5 people. And I just found out from Wikipedia, I promise this is true, that Stripe is over 2,000 employees now. So that's a heck of a ratio, 1 to 5. That's the goal, right, for design systems. Their leverage. A dedicated team of 4 individual contributors can abstract and maintain the design language and technical implementation for a component library for 2,000 people. How's it going? It's fine. It's good. I think it does a good job. It's not magic, despite my most sincere efforts. That was a great talk, by the way. I think we create more value than we remove. I believe in our goals, and I think my coworkers and teammates on this team are some of the most thoughtful and capable people to be working on this problem in existence. So we've done nifty work on accessible color systems, applying a lot of magic to choosing one. And we've made building consistent Stripe-looking interfaces a little bit easier. And we have some or another version of just about every component that you can think of, often to our detriment. This is massive work. Design systems are hardly a new concept. You don't have to look much further than an old NASA graphics standard manual from the 60s and 70s to find cool old design systems. But there are very new challenges, especially technical ones, that compound on the old challenges. The complexity is multiplied. Robin Rendell recently wrote an essay that compared design systems to the idea of a hyperobject. And that idea resonated with my team very strongly, and with me. He's referencing a book by James Bridle called The New Dark Age. It says, a hyperobject is, I'm going to read to you, a thing that surrounds us, envelops and entangles us, but that is literally too big to see in its entirety. Mostly, we perceive hyperobjects through their influence on other things, a melting ice sheet, a dying sea, the buffeting of a transatlantic flight. Hyperobjects happen everywhere at once, but we can only experience them in the local environment. In fact, they stand outside both our perception and our measurement. They exist without us. Because they are so close and yet so hard to see, they defy our ability to describe them rationally and to master or overcome them in traditional sense. Climate change is a hyperobject, but so is nuclear radiation, evolution, and the internet. I agree, that's very dramatic. Design systems are not climate change. They do often feel like sneakily complex systems. Like no single person can hold the whole thing in their head anymore. It's like trying to figure out what shape the crop circle is from inside the cornfield. You can spend an incredible amount of time thoughtfully tackling an issue, only to zoom out and zoom out again, just to see that you're working on a tiny subsection of your design system. And that idea really sums up a lot of the work that's involved in the second and third waves that are needed to be put into a design system. It's all about trying to make the entire thing useful while also making any arbitrary subset equally useful. To not require each person, each user of the system to hold the entire thing in their heads. There's, of course, lots of information that exists on how to create a design system. There are books and tutorials, and how to jump past a lot of the difficult pain points. That's not my focus here, but I certainly would be lost without all that prior art. So I'd be happy to recommend some of that if you want to chat later. When you first get started on a design system, you have some fundamentally different and often opposite goals as when you're trying to level up an existing design system. When you first get started, you want to make lots of new components. Your goal is coverage. You want to maximize the number of designs that are possible with your system. You work on selling people to use it versus rolling their own components or doing one-off designs. And you actively seek real estate in your applications to see what you can replace with a cleaner design system version of a thing. You want people to be excited about using your design system. Once you hit critical mass of adoption, your goals start shifting pretty quickly. You worry more about keeping the system healthy and alive, not about selling its value directly. You fight to make sure you don't become too dated, but for the most part, you hit a stage where your goal is to blend into the platform. One of my favorite 2019 goals on my team at Stripe was that another team would announce a conversion of their application to our design system without thanking us at the end of the email. Our goal was to become part of the expected platform rather than an exciting tool that people have to think a lot about. It happened. It was both frustrating and very exciting. Another surprising change in this second phase is that where you once judged yourself on how many components you added in a quarter, you start valuing the opposite. Whether it's crufty old components that never did the right thing anyway, or super specific components that could probably be achieved by customizing generic ones, you quickly appreciate the things that reduce the system complexity. Your primary goal stays the same as before, though. It's to provide a system that adheres to your values, so the resulting UIs adhere to your values. A really common design system thing I see, sometimes even attached to goals for your business metrics or something, is a desire to add components in perpetuity. I think this happens for two reasons. First is the idea that the more components you make, the faster it will make developers, and the more useful the library will be. I think this assumption comes from a good place, but I've never seen it play out in practice. A very solid core of atomic components can be well understood and composed and recomposed by your users in unlimited permutations. If you build them well, you won't have to fit new ideas into old components. The faulty assumption is that having a component that does something close to what you want makes you faster. But when I think back to the most frustrating wastes of time in my career, it's almost always in trying to configure some mega component to do one thing that it wasn't quite designed to do. So fight for atomic components. It doesn't mean your applications shouldn't make their own logicless, complex, non-atomic components that they share between the app. But it just means that those components probably shouldn't live in your design system. The other reason I see engineers continuously add components is that they actually have a secret desire to rewrite the things that they don't own at the company. I know this sounds like conspiracy theory, and I'm sorry for that, but I'm going to keep going. It does follow a pretty natural evolution. First, you fix all the buttons, and then you fix all the menus and tabs and cards, and eventually you're out of kind of the atomic seeming components. You still want things to look better, and so instead of stopping, you find yourself searching for any patterns that are reused more than one time to turn into components. Oh, here's a person card and a detailed person card. We could kind of smash those together and retake that land. Suddenly, they're pretty business specific and pretty application specific. And then you want the pricing page to look nicer, but it's so entrenched in the old stack that no one will touch it. So eventually you throw off all pretenses of component reuse, and you build the pricing banner component, throw it in the design system, and then replace it. So you don't have to look at it anymore. We have, I have these urges, everyone has these urges, but I'd recommend you work these things out organizationally rather than declaring manifest destiny on other teams' technical debt. You'll like your design system more in the end. I want to dig back into the first point I brought up there, though. There's this common perception of design systems that they're intended to increase efficiency. I don't think this is entirely wrong, but I think efficiency is a secondary goal of a design system. The primary goal of a design system, in my opinion, is to uphold your values. Design systems are so you can ensure that when a developer is making trade-offs to ship something before a looming deadline, that thing falls off the chopping block, that the thing that falls off the chopping block isn't accessibility, or performance, or visual consistency, or all attention to detail. Design systems are tools to uphold the quality of your product, even in the face of consuming teams that aren't paying particular attention to quality. A design system is successful when someone can throw together a quick application, and while that application may fail to achieve the specific business goals, it still upholds the values that are otherwise left behind in crunch time. It's accessible, consistent, performant, and whatever else you've decided is important to you. One of my first actionable recommendations is to fight against the wrong contextual specificity in components. It's very common to end up with a lot of similar components that often do almost the same thing, and maybe even describe the context that they're used in. Icon, button icon, action icon, menu icon, all are seemingly icons. It's also common to recognize this complexity and then move everything over into a single component, and you end up with kind of like an explosion of props that all do something very specific only for one use case. You can't always avoid one of these traps, but we want to move in a direction that tries to allow the context to dictate the differences, not a bunch of props. So let's see if we can contextually create a button icon, which is the one at the top there, without actually needing a component like that. You notice in this example from the striped dashboard, we have two icon types visible, one icon inside the button and one outside. They're mostly the same, but the one inside the button is 12 pixels, and the one outside the button is 14 pixels. That's your difference. I mean, they're also different icons, but relax. I'd expect many people's first iterations to look something like this. We add a prop directly to button to declare the type of the icon we'd like it to contain. Icon equals gear. You can imagine it puts a gear into the icon. But then we recognize that in order to change anything about the icon, we'd actually need to duplicate all the props from icon onto button. So if we wanted to change the size, we'd have to like add an icon size prop there or an icon style prop to grab them all. That's possible, but not pretty. It stands out to me that button also must now import icon, whether you use it or not. So let's try another approach to try to separate them. Put it directly inside the component like this. So now we put an actual icon inside an actual button. This is great, and we could be done, but like I said, sadly, icons are 14 pixels by default, and the icons inside of a button are 12 pixels by default. We could make a rule that says all developers must remember to change the size to 12 when they put an icon in a button, but we all know how well that would go. Our complexity of our system is leaking out. We have a dependency between button icons that we're not describing well. So rather than require each developer to remember this on their own, we could make a new component that's mostly an icon. Maybe it even wraps an icon, but sets the button defaults instead of the regular icon defaults, in this case being 12 pixels. But we're back to button icon again. This is where we started. This is the hyperobject in action. A user of our system has to know about all the quirks involved in icons versus button icons to know that they want to put an icon into a button. Then they have to actually use a different type of icon, not an icon itself. Then they have to learn the specific thing about the system. They have to hold a lot more in their heads in order to use it. Also, what happens if someone doesn't know about button icon and just jams an icon in there anyways? Then you are mixing 14 pixel and 12 pixel icons. Shame. One approach to solve this that we could take somewhere in the middle of the two solutions is allow a regular icon to be passed into the button, but make it a prop, rather than something that goes into the children. The button can safely override the icon, add the 12 pixel size, before injecting it into the children inside the code. This was initially pretty attractive to me, but I think it still leaks complexity back out to the user. We still have the initial problem where we have to add special icon props. Like icon position starts to be an issue here. And we still don't prevent someone who doesn't know about these props from just jamming an icon directly into the children. We can fix that problem and kind of paper over a few more by getting rid of children entirely, which is a technique that is often used. We can replace the functionality with a label prop. It's not pretty, but it feels like it probably meets our goals in this specific case, but maybe not many others. I don't feel great about this. It feels like button just got a whole lot uglier, and using the entire system feels less regular. I think as a user, I might be compelled to just skip using the design system button and kind of roll my own and make one myself. In my opinion, we have to work backwards from the goal state. Users can reason really well with their original solution. This is actually not our original solution, but the second solution, and just put an icon inside the button. You don't need to know anything about the system in order to write this. This is just composing two atomic pieces, possibly the only two you know. And if it did what we wanted, this subsystem would feel closed. We have to just solve for the problem that the icon should be smaller when it's inside of a button. So how do we do that? It seems like we have to either make icon aware of when it's in a button, or we have to make button aware of when it contains an icon. So let's try the latter. Inside of a button, you don't have to actually read this too closely. We can enumerate each of the contexts that it knows about to try to render something different and adapt to its surroundings. So we have this kind of thing that I'm abstracting out called is in button. Is this icon in a button? This is not ideal. If we can be rendered into multiple things, there's this combinatoric logic of am I in a card and a button and a something, and it just explodes. Also, like, are we doing upwards tree traversal in order to determine that? It seems all pretty plainly not nice. So here's our goal state again, just to try to recenter us. Let's try flipping who knows about who. Maybe we can make the button find and change icons that are inside of it to be a smaller size. This is actually pretty similar to our real first idea, where we just added an icon prop, and that felt pretty natural, but it's not a great solution for the same reason, because the button needs to know about and possibly even directly depend on icon. You get some weird code like this, where you have to import icon from the button, and then you have to search down into the children to see if it contains icons. Like, this is clearly maybe not a very tenable solution. It's about as ugly of a company as I could think of, actually. I know I can be less obviously silly and write some CSS. This is better, but it's still pretty sad, because now regardless of whether we need an icon or not, every time we pull in button, we also have to pull in all or part of icon. It becomes somewhat clear that trying to resolve this is our primary objective. Our primary objective is to decouple these two components. Neither should depend on the other. So we want to create relationships without encoding strict dependencies. This is a theme. This is pretty similar to the goal in denormalization in databases. So two models share a common value, so we can either have them fully depend on each other, be in the same row as each other, or we can create a reference to a shared value, kind of like a foreign key. To solve this, we've added a new concept to our design system. It encapsulates this same idea. It's a shared value. We call these values tokens, but you don't have to. That's certainly an overloaded term. It's a tiny shared dependency that holds a value, remembers the context that it's set in. In this case, it determines the size of an icon. Either component is free to write or read from the value, or stop doing anything with the value at all. In this specific case, we have icon size token. It's 14 pixels by default. Icon would use this value to determine its width and height, and button would override this value for any of its children. So it looks like we have an icon inside of a button, and it's going to read the value through the context of button and see that it's 12. So this is our solution. It also means that you can delete button entirely from your application, and things keep working. Or you can delete icons from your application. Maybe you have a weirdly named token, but everything stays working, and neither file depends on the other. We still have a directed acyclical dependency graph, the old DAG. For my graph nerds out there. So these are now atomic components again. Our final solution doesn't look very interesting to an end user. That's the goal. It's exactly this first most natural idea that we had before. But now thanks to the token that encodes the relationship of a shared value, the user doesn't have to worry about the icon being the wrong size in the wrong spot, and they also don't have to bring along their own icon just whenever they import button. They only carry tokens. They encode relationships without creating strict dependencies. Our goal in separating buttons and icons like this is to make sure that each component isn't reliant on the other. The token idea is just one illustrative part, not some silver bullet, of creating a system that doesn't leak complexity all over the users. A theme that arises when you think about these concepts is decentralization. If your goal is to be able to avoid needing the entire system in your head, then it makes sense that decentralization becomes a critical property of things you add to the system. But centralization is difficult to avoid, and it can be very sneaky and bite you from all over the place. Consider the button and icon example from before. We had two totally disparate atomic components, and just trying to make the icon size 12 pixels inside of a button causes us to create a dependency in one or both directions, which is super rough. There are other pretty common feat guns that aren't super obvious as well. Configuration stands out as a major point of centralization. We have a big system that all functions independently, and we often jam every option for the independent pieces into a giant JSON file at the top. This points at a flaw in the way we think about configuration, in my opinion. It's a top-down global store of variables to be set by the consumer of your system. We've all been warned about global variables before, I'm sure. Configuration is often contextual. Configuration begets more configuration. What we're really trying to achieve when we make something configurable is giving control over something to the implementer. Luckily, there are patterns for this other than just shared global constants. On our team, we've leaned into the idea of inversion of control for configuration. We use exportable tokens, that same token system that we used before. And they can be overwritten at each level of application hierarchy, kind of like context can be. You can declare your configurable tokens where they're used rather than at the top. This leans into our decentralization goals. Imagine instead of setting a global brand color, you imported the brand color token from the colors module and overrode it or aliased it. And then any child component that used brand color would get your updated value, much like the 12 pixels example. The configuration becomes code, but that code can live anywhere, not just at the very top. Theming in general is the best use case that we've seen for this. We can start with a color set that's imported and overridden and remixed all throughout the app. And the equivalent centralized config would be thousands of lines of JSON here. Another thing that you can kind of inject into this idea of inversion control is internationalization. It's a great pattern for internationalization because my rough advice, and I do a lot of work with internationalization, is that your application already has to solve internationalization problems. So rather than solve them again, just seed control back out to the application. Each user of your design system may be using different localization tools and embedding internationalized formatters and message bundles. And doing that also in your design system could bloat it to unusable levels. So you want to avoid creating a parallel internationalization system that's used in the application. This is good for performance and just cleanliness. So it's not a huge leap to say that instead of rendering internationalized text as the default label for your button, that you'd use the approach that we've been discussing to allow applications to override the formatters to match ones that they already use. Yeah. The key to a well-internationalized design system is really just being a highly composable design system that gives control over to a well-internationalized application. Last kind of idea that I want to talk about is one that we're kind of playing with right now still. We are looking to mimic some of the patterns in Swift UI from Apple, and there's been some interesting fallout from that. One interesting property of Swift UI, if you're used to modern JavaScript frameworks, is that you nearly always start with a single root level component, rather than the somewhat more common higher order components model, where components wrap other components wrap other components. They call these blank slate base components of view, and so we do too, but you could call it a box or a component or something, whatever you want. Another property of Swift UI is that an in-order set of modifications called modifiers, surprisingly, that is run on that base component. So you can think of that as a set of transformations. So what are we transforming? In our React brains, these are just transforms on the children or the props or the state or the attributes, the kind of 4 things that you have control over. And in this example, we first take the content, we add the padding, and then we add a background color, and then we add a foreground color, and then we change the font. It's procedural, which feels kind of weird, but also maybe kind of cool. And just calling on this, we call it on the content itself. We just return the content with the dot padding on it. I don't know, it seems cool. So we tried it out. We kind of put a similar idea into a React component. The view component starts with no children or state or props or attributes, and then each modifier has a job to add, modify, or remove one or many of those things. When you think about this, you can actually drop frameworks out of the picture. They're mostly irrelevant until you're done building up the set of those children, state, props, and attributes. But this happens after all the modifiers run. You can use your framework of choice to render that actual set. This is kind of magic for a few different reasons. The first is that you have an audible list of transforms that you add to your component. It makes building up a component really easy to observe. First, we add some text, then we add a CSS class, then we add an on-click handler, then we update some state. Instead of sharing a button component itself, you can actually share just the list of modifiers that a button has. That means components are always only one level deep, which vibes really well with our goals around sparse dependency graphs between components. And we're just passing around little groups of these little transforms now. This concept is a little easier to understand when you see it. We were able to put together a little modifier step-through viewer. The top button with hello world in it is the end state, and then each checkbox turns on a different modifier, and then you can kind of eventually see that come through. The projector contrast hurts it a little bit, but maybe it's still close enough. This is the array of modifiers that we're kind of turning on or off. Second reason this is magic is the bit I mentioned before. Pretty much none of this has anything to do with a framework until you need to render the actual component. So you're just generating and transforming the configuration for a future component. Then you have to turn your children, state, props, and attributes into a rendered component. So nearly all components can be described as a set of modifiers instead of as unique components. And that means your design system components can be described outside the bounds of a single UI framework. It means we can write a renderer in React, but it also means we could write a renderer in Svelte or Vue, or even something like a Sketch or Figma plugin to automatically get our components into a design tool from code. This is a powerful idea. There's still a bunch of work to write these renders. It's not a panacea, and some things like a date picker so far have been a little too interactive to get in this magic framework agnostic way. But if design systems are about upholding the values of your company, it's unlikely that those values will change just because something is more trendy than React now. You should build up a system that encodes your values, and you should write a renderer that displays them in the cool frameworks that your teams want you to implement, even if those frameworks change over time. So what does success look like? I have no idea, of course. We're not even close to success. We have 2 phone number inputs. I don't know why. We're hardly at the fully baked stage of any of these ideas, and I want to discuss them with you for that reason. But it definitely feels like there's a thread throughout all the solutions and problems that we're facing. Design systems are hyperobjects, so we need to make design systems that contain closed subsystems that are comprehensible. That starts with making atomic components that favor extremely small dependency trees. An atomic component is its own complete closed subsystem, and any arbitrary set of those subsystems can be composed into increasingly larger closed subsystems. That's a sentence. Decisions are decentralized. Components are tied together via ceding control to each other and based on the order of their composition. Your values are deeply connected and encoded into the technical implementation, but not tied directly to the framework of the week. A successful design system can describe intent without needing React. More than anything, though, a good design system prioritizes upholding values over everything else. It facilitates the increased likelihood that applications are built with it also share those same values. Thanks.